In this example, we're going to look at another trig equation. This one's a little bit more complicated and requires a little bit more work. So you'll notice here we have the function sine of 2x. We're trying to solve the equation equal to negative 1/2. We want to find all the solutions in 0 to 2 pi. So first things first, we need to rewrite this as with a single variable in there. It's a lot easier to talk about reference angles and stuff when we have a single variable in there. So I'm going to rewrite this as u equals 2x, and then I can write my equation as sine of u, so I don't have to think about that. And this works whether that's a single 2x in there or if that's a sum like 2x plus pi inside the sine function. Any of those kind of things it's going to work for. So once again we find the reference angle. Remember, the reference angle would be the thing that would give us a positive 1/2. And we pull that from our memory. That's pi over 6. And then just like we did previously, we're going to use that reference angle now to put the reference angle into the quadrants where sine in this case is negative, since it was negative 1/2. So sine is negative in the third and fourth quadrants. It's positive in the first and second. And so we put pi over 6 into the third quadrant and the fourth quadrant. In the third quadrant, it's that much past pi. So d pi plus pi over 6 would be 7 pi over 6. Then we would put it into the fourth quadrant. It would be that much short of 2 pi. So it would be 2 pi minus pi over 6 is 11 pi over 6. I absolutely am not forgetting something, but if these were the only two answers I wrote down here, yeah, there would be a problem. Because there is an important idea that we haven't touched on yet. So we started just like before, but now there's some more work to go. And to kind of explain that more work, let me go back up here and notice that we're trying to find all solutions of x that are in 0 to 2 pi. But our angle isn't x, it's 2x. So u is actually going to range between 0 and 4 pi. So that means we actually have to look at another turn around the circle. So to find those new angles, we just need ones that are coterminal with the ones we already have. So we can do that by just adding 2 pi onto the angles. So 7 pi over 6 plus 2 pi would be 7 pi over 6 plus 12 pi over 6 would give us 19 pi over 6. And likewise, take the 11 pi over 6 plus 2 pi, or 12 pi over 2, or sorry, 12 pi over 6, and we'll get 23 pi over 6. And then anything bigger or smaller than that will be outside the interval, because 23 pi over 6 is just short of 4 pi. So the next one would be way too big. So now that we've done that, we're still not quite done the problem because we wanted to solve for x, not u. So what I'm going to do to save a little bit of writing is I'm going to take the u away and replace it with what it's equal to. This is again just serving kind of as a little intermediate step there to clear up the notation a little bit. But now it can go away. And we need to solve for x, so that means we need to get rid of the 2. So we can do that by dividing by 2, or if you prefer, multiply each one of those things by 1/2. So 7 pi over 6 times 1/2 would give us our first answer, 7 pi over 12. 11 pi over 6 times 1/2 would be 11 pi over 12. And then 19 pi over 6 times 1/2 would be 19 pi over 12. And 23 pi over 6 times 1/2 would be 23 pi over 12. And every one of those answers now for x is between 0 to 2 pi. And we know that because we made sure that every one of our previous answers fell in that proper interval of 0 to 4 pi. And so now we have our solution here. 7 pi over 12, 11 pi, 19 pi over 12, and 23 pi over 12.